Hi, I'm Pat Kelly. Okay, in this problem, they give us this vector field given to me here in orange with my f equals. And the directions ask us to first find the magnitude of f, but then also to sketch several representative vectors in the vector field. And you can see I'm ready to do that as well. So we'll begin by finding that magnitude, which you know how to do, right? It's the square root of, and then you're looking at your component for the I vector, which is -1 here, but you square it, so I get a +1. Then you add, we look at the j component, which is 3y, but square that, and we get 9y squared. I'm going to close the radical hat, and that's my answer. That's my answer for the magnitude. So now why would we do that? They asked us to find the magnitude, but even in a different problem, you'll want to do that for yourself, because the next thing we're going to investigate is where the vectors in this vector field would have the same magnitude, some fixed value. So in other words, let me come up here. We're talking about the magnitude of our vectors equaling some specific constant. I don't even care what that constant is. For me then, I know this magnitude of f is my square root of 1 plus 9y squared. And we're looking into when that equals some constant c. And I'm actually done with my work there for this problem, because what I'm seeing is the magnitude here, no matter what value of c you might throw at me, depends only on y. Okay? In a different problem, you might go further with that, because what you might try to look for is a relationship specifically between x and y. If you push this equation further in a different problem, you might get the equation of a circle or a parabola or an ellipse. And what that would tell you is in the vector field, all the vectors on that circle would have the same length. All the vectors on that parabola would have the same length. For me, since my magnitude only depends on y, I can pick any y value that I want when I go to draw in the vector field, which I'm going to, like y equals 0. And if I pick a y equals 0, every vector that starts there is going to have the same length. If I pick a different value for y, like y equals 2, every vector I draw there will have the same length. So you're doing that work to try to get a feel for where the vectors are that will all have the same length as each other, and where the vectors are. Okay? All right, now let's draw some of those vectors in this vector field, the second part of the problem that they wanted. Switch colors as well. So what I'll do is I'll pick points, and I can pick any points that I want. So I'm going to pick like a 1, 0. I think I might also pick a 2, 0. And I'm also going to pick a -1, 0. I'm not trying to go too fast, because I'm actually going to pick several points, several more points, and for each one of them, I'm going to find the vector that corresponds to what I will draw in the vector field. But I listed 3 of them right off the bat, because I want you to notice they all have the same y value. And that goes back to what I was discussing. When I go to draw these vectors, I can anticipate that each of these 3 vectors that I'm about to find will have the same length, the same magnitude. Okay? So let's find the vectors for each point by taking your x, y and plugging into your f formula, your function. So the first part of it is -I. There's nowhere for me to plug in the x value. Plus 3 times y. 3 times y here is 0. 0 times that j vector. This I is a vector as well. Okay? So when I go to draw that now, at the point 1, 0, that's your terminal point now. You draw the vector -1i plus 0j, which means 1 to the left, and then 0 up. So I'm going to have this vector. Okay, now let's come over here and draw another one. For 2, 0, put in a 2 for x and a 0 for y. Up here, again, it's -I plus 0j. Okay, so I come over here, and at 2, 0, that's going to start here. let me actually correct myself. If I called that the terminal point when I first drew it, but that's your initial point. The terminal point is where our arrowhead ends. This is my initial point, 2, 0. To get to that terminal point, I got to go -1i plus 0j. So 1 to the left and 0 up. So just straight over and arrowhead. And I'm done. And see how those look like they actually have the same length. Let's do the third one here. The initial point is going to be -1, 0. I'll plug the xy into my f up there, and I just get -i plus 0j again. Okay, come back over here. I wanted to grab one that had a negative x value, so your initial point is going to be -1 here, 0. And then we're going over 1 to the left and up 0 again. So that's just going to look like this vector. And again, everything along here looks like it's going to end up with the same length. That's the work that we looked at already. Okay, now let me go down and grab a couple of more points. Down here in my table. And I'm going to grab a y value of 1. You pick whatever values you want, really for both x and y. But I like to see my y values being the same here. Let's do a 1, maybe a 2. Find the vector by going into your f equals again. This one will have a little bit more to it when I plug and chug. That's always just -i. And then plus 3y. This time my y is 1, so plus 3 times 1, and then j. And then when I go to draw that guy, I'll start at 1, 1, 1, 1, terminal or initial point, and I'm going 1 to the left, so over 1, but up 3. 1, 2, 3. My vector is going to look like this. Okay? And then my other point that I picked with a y value of 1, x of 2, go up to my f equals, and I get -i, and plus 3y, so plus 3 times 1, plus 3j. And now my initial point of 2, 1, 1, 2, 1 is here. And 1 to the left and 3 up. So 1 to the left and then 1, 2, 3 up. I'm looking at this vector. And again, I'll argue those two vectors look like they have the same length. If you picked any more points with a y coordinate of 1, they would all look like they have the same length. I'm going to go for 2 more because I want to draw 2 more places where I have a different y value. Let's say -1. And then maybe a 2, -1. I'm plugging x, y into the f equals, so I'll get -i again, plus 3y, but this time my y is 1, so that's going to be a -3j. And let's draw that one. -1, -1 has an initial point there, 1 to the left, and then 3 down. So 1, 2, 3. I'm looking at that vector. Okay, last one for us, I think this will suffice. Plugging in x and y, I get the I plus 3 times y, but my y was negative, so -3j. So at 2, -1, 1, 2, -1, we'll start there, go to the left one, go down 3, 2, 3. And if my drawing's somewhat decent, those two guys look like they have the same length as well. Okay? Hope that helps. Practice them on your own.